Afternoon, dear students. Today we'll see the topic curve fitting. Now, many a times data is given in discrete form, like we have this x and y values. X is given, there are 7 values 1, 2, 7, and corresponding values of y is 0.5, 2.5, 2, etc. Now, here we need to find out what is the relation between x and y, because we do not know intermediate values. Say at x is equal to 1.5, what is the value of y? We don't know. So for that we need one relation between y is equal to something, that is, it is the function of x. So there are number of methods for finding out this relation. First method is, now we have number of discrete points x and y. So here we can use this pattern of the discrete data and directly we can fit one straight line. Okay, it is not compulsory that this line should pass through all the points. So this is called least square regression. Okay, second method, here again with the help of straight lines we can join these points, directly join these points with straight line. The line is passing through these points. So this is called linear interpolation. Okay, and third method is, now the points are same. Here we will join these points with one, say, second degree curve or parabola like this. So this is called curve linear interpolation. So in the first case, the line is, it is not compulsory that line is passing through all the points, but for the second case in linear interpolation, line is passing through all the points, and in third case also the curve is passing through all the points. Next we'll see how to fit one straight line using least square regression method. So here we have discrete data points and we will fit one straight line to this data using least square fit method. So here the equation for one straight line, you all know it is equal to y is equal to, say, mx plus c. You have studied this during your school days, okay, where c is the intercept and m is the slope. Similarly here we will use this y is equal to a0 plus a1 x. So what is this? a0, it is the intercept, and a1 is the slope. Now this is the equation of this line, this red line, okay, and these black points, this is the measured points. So always there will be one error. Error means, for example, if you take this point, this is x2, this point is x1, corresponding value is y2. So this y2 is the measured value, and if you see this equation y is equal to a0 plus a1x. Here if you put x2 in this equation, you will get y2, that is modeled one, a0 plus x2. Now this y2 modeled is this one. At x2, using this equation, if you see this y2, this is the modeled one y2, this y2 model, and this value is y2 measured. So always there is certain error when we are using this equation. So we will write this equation, modified equation, y is equal to a0 plus a1x plus e, where e is the error, or it is called residue. Okay, and we will write, rearrange the equation. E will be equal to y minus a0 minus a1x. Okay, so here now this equation is for a single point. So if you want the equation for entire points, so we will perform the summation. Okay, summation of this equation, that is summation n is equal to 1, I equal to 1 to n. N is the number of data points, n so I equal to 1 to summation n. N is the number of data points. Suppose we have 7 data points, so n will be equal to 7. So it is summation of this error for these 7 points will be equal to summation I equal to 1 to n bracket y. I know this y will become 5, I means number of points 1 2 3 4 minus a0 minus a1 again xi. Okay, now for the best fit, means for the best fit of this line, we need to write this error in the form of this equation, that is SR is equal to summation of I equal to 1 to n e I square. You see here error square, so this SR means square of the residue. S refers to square, R refers to the residue. Residue means this E. It is equal to summation of I equal to 1 to n y I measured minus yi model, which we had discussed, this measured value and model value whole square, and it is equal to, now this e is, this difference is nothing but this equation, I is equal to 1 to n y I minus a0 minus a1x I whole square. Now for the best fit, what we need to take the derivative of this SR, okay, with respect to this A0 and A1, because we need to find out A0 and A1 in this equation here. See, in this equation we need y is equal to A0 plus A1 into x. So these two are the unknowns. So differentiate SR with respect to these two unknowns. Dou SR upon dou A0. We'll take partial derivative because we have two variables. So it is equal to, it will be 2 summation of yi minus A0 minus A1 xi into, where the derivative is with respect to A0, so derivative of A0 is minus 1, so this here will be having minus 1. Next, derivative of SR with respect to A1 is equal to, so again it is 2 summation. The summation sign is always I equal to 1 to n, okay, I equal to 1 to n, and it will be equal to what, yi minus A0 minus A1 xi into xi, because we are deriving with respect to A1. So here derivative of A1 will become 1 minus xi. Okay. So this is the minus sign. Now we know that for finding out minimum value of this SR, we have differentiated it and equated to 0. So 0 is equal to summation of, now this minus 2 cannot be 0, so it is yi minus summation A0 minus summation A1 into xi. Second equation, this 0 summation yi into xi minus summation A0 xi minus summation A1 xi whole square. Okay. Now this summation of A0 is nothing but n times A0. Summation of A0 is nothing but I equal to 1 to n. So n times it is summed, so that is n into A0. So here if we put in the previous equations and simplify, we will get A1 is equal to n into summation of xi into yi minus summation of xi into summation of yi divided by n into summation of xi square minus in bracket summation xi whole square. Okay. Now whenever we will tell summation, that is I equal to 1 to n. So this is, we got A1 a0 is equal to summation yi upon n minus a1 into summation xi upon n. Now this summation yi upon n, it is nothing but the mean. So we can write a0 is equal to y bar minus a1 into x bar. X bar is, it is the mean, y bar and x bar. So now we got a0 also. What was our equation? Y is equal to a0 plus a1 x. So we got a0 and a1 with this. So we have got this equation, this relation, and this is the equation for straight line.